Agenda of today. Okay, we're going to be revisiting the two main disinfection byproducts that you see in public pools, combined chlorine and THMs. Then we'll talk about 4 ways to treat water in public swimming pools.
If you want to achieve a combined chlorine level below 0.2.
Yep. Disadvantages of UV medium pressure lamps, which I know we have a lot of UV medium pressure.
Yeah. We will talk what they can do and what they cannot do.
And we will introduce an alternative to UV medium pressure that we are just introducing now in Europe. We wanted to share this with you because this is most likely or very likely something we're going to bring to the US later.
Absolutely, we will. But we do it a little bit like Tesla. You know, Tesla, when they launch the new Teslas, they launch it in the US. So if there is a problem, you can fix it quicker. And we go through the learning curve here in Europe, and then we come to you.
Exactly.
When we are mature.
Yes.
But it's good. It's world new.
Exactly. So as always, we're looking forward to answering your questions. Please use the chat function to type down your questions as you go. And as always, everything is recorded. You can watch the replays on our website, and you see the program for the rest of the sessions and the presentations in PDF available for download.
Yeah, and let me add something.
Yes.
We will somewhere next week, we will upload all the sessions on our YouTube channel in 3 different languages. English, German, and French. And the English we will do in 2 versions: the US version with the imperial system, and the metric version. So you can always go down and rewatch it or share it, or if you want to train some of your new staff, maybe a good idea that you say each week you watch 1 video and maybe you answer 2-3 questions, so you're sure they watched it.
Okay.
Good.
Excellent. Good. Okay, so let's get started. In session, I always forget, was it 4 or 5? 4, I believe. We were talking about chloroform. We want to revisit this real quick. How are chloroforms being formed? So remember, we have large organics in the water, and they are being chopped down by chlorine into smaller molecules. The smallest one that is left is what's so-called methane. It's 1 carbon and 4 hydrogen atoms. This now continues to react with chlorine, a substitution reaction that replaces 1 of the hydrogen with chlorine. It continues to 2 chlorine and then 3 chlorine, and that is ultimately the chloroform.
3-chloromethane. Yes.
Exactly.
And I know we are brainwashing you. We told this 3 times or 4 times, and we will maybe say it even another time because it's really important. You know, chloroform is very volatile, it gases out, and it's not good for your health.
Exactly.
And the other really good message is with AFM, especially the NG, you remove 50% more organics, you have 50% less of chloroform. And it's important, even if you're not measuring it yet in the US, it will come at a certain point because it's really the one that we do not want. So that's really the product promise of AFM. You will have much less of organics, clear water, and from a health point of view, much less of chloroform.
Much less of chloroform, exactly. The second disinfection byproduct we were talking about are the chloramines, or especially the trichloramines. Okay, remember how trichloramines
Let me add one
are
thing
being
before
formed.
you come to the trichloramines. What is not the promise of AFM, that you will have in indoor pool much less of total combined chlorine. This is not the promise. The promise is much less of inorganic and especially much less of trichloramine. Let's briefly talk about trichloramine. Sorry, I stopped you.
Yeah, yes, you did.
Yeah.
Okay, so how are trichloramines being formed? The main food source for bacteria is what swimmers actually bring into the pool. It's pee, it's sweat, it's skin cells, and so on. You can see the quantities here that a bather can bring in are quite significant. Some sweat more and others pee more, but it's a significant amount. And what is that? The main component of what people bring into the pool is what's called urea.
80%, 80%. Urea, it's organic, it has a carbon in.
Yep. And about 10% ammonia. And then those two, you can forget. You can ignore those, right? But urea is really the...
80, 10.
Absolutely. So what happens now as urea enters the pool? Urea is being converted by bacterial enzymes that live in the biofilm, in the sand filter, into ammonia. Ammonia will react with chlorine and will first form a mono and then a di and a trichloramine. The trichloramine is what gases out of the water and what is responsible for chlorine smell, eye, and lung irritation.
Yeah, but the important thing is here. Now, if you have a bioresistant filter media, AFM, or also DE, the urea will stay urea. You have 80% urea. And 10% of ammonia.
Yep.
So the ammonia can react to monodi and trichloramine, but only 10%. And the urea will form organochloramine that we will see later on. If you have bioactive filter media, sand, you have the biological growth, you have the biological conversion, all this urea, the 80% will go down to ammonia. So you end up with 0 urea, 90 ammonia, and therefore you have much more of inorganic combined chlorine. Ladies and gentlemen, I made it now a little bit black and white, you know, with 0 and 90. It's not like this. It's maybe then with 10 or 20. Depends a little bit on the biological growth that you have, but just to make it clear. Did you understand this, Sean? Was this clear?
Absolutely.
Good.
Good.
So both of these are volatile. We discussed it, and go one more are volatile, and it's really from a health point of view, it's the volatile disinfection byproducts which are a problem.
Oops.
Okay.
Roger,
we have a problem.
TV is
TV will
Let me click on. Maybe I can click on this here.
No, you can't. You just mess it up. Okay, he fixed it.
Okay.
Great.
Good.
So we breathe them in because they are volatile. They are above in the air. We breathe them in. They come in our lungs, and trichloramine are not good. Chloroform is not good. Trichloramine will remove the protective layer that we have on our lungs. If we are often exposed to high level of trichloramines, we are dolphins. We get the lifeguard lungs, asthma. The chloroform will pass in your lungs, in your bloodstream, and it's an anesthetic. I mean, it goes on your nerve system. It does not make you smarter. It's like with alcohol, I guess. It does not make you smarter, and especially for babies, it's really, really very toxic, because before their blood-brain barrier is fully developed, you know, it really goes directly and can create some damages, also for pregnant women.
Yeah.
So we talked about this, but it's so important that we wanted to say it again.
Okay. So let's clarify this thing with the combined chlorine and then the inorganic combined and the organic combined, huh?
Exactly, and this is where we start here. You know, again, I said the promise of AFM, much less of chloroform, but it's not the promise less of combined chlorine. I know that's very repetitive, but let's do it again. With DPD1, show it, you measure the free chlorine. If you add in this DPD1, then a DPD3, you get 1 and 3, you get DPD4, which is the measurement for total chlorine. The difference is the combined chlorine. And now here we have two streams, the inorganic that we have seen, ammonia with chlorine, monodi and trichloramine, and you have the organic chloramine. One step more, which, you know, if we stay with the urea, the 80%, that will also react with chlorine and form an organic chloramine. Organic chloramine has a Henry constant of 0. That means it's not volatile at all. Not volatile at all.
It stays in the water.
It stays in the water, and therefore we can have the same amount of total combined chlorine as a sand filter. Maybe even a little bit more. Usually a bit less, but maybe even a little more. Because if you have trichloramine, it gases out. That means you move the problem to the air, but your water is getting better. If the trichloramine gas is out, your combined chlorine level in the water goes down. So there are also some tricks that you can play, but I think that's the really important one. And as a consequence, we end up here with the yellow and the red arrow. Philip, you are
Yes,
You're
the green.
American. Explain
That's
us
green.
this.
That's green.
Green
That's not yellow, huh?
Yeah.
Okay.
Sorry.
Yeah. Okay. So with AFM, we dramatically reduce the formation of these inorganic chloramines because we don't form the THMs, but we
It's not the THMs.
the
Just
inorganic, the trichloramine.
10,
I mean,
maybe
the trichloramine.
20% inorganic.
And then we keep the urea in the water. The urea will react with chlorine and form these organic chloramines. But as Dominic explained, they are not harmful because they stay in the water. With sand, it's the opposite. With sand, we produce a lot of inorganic chloramines, and we don't have much urea left. So subsequently, we don't form a lot of organic chloramines.
And let me come back to the DPD measurement. You know, the DPD1, DPD3, you know, is quite a good measurement if you have sand filters, but it's not really a good one if you have AFM or let's say also DE. Yeah. By the way, this is the DPD1, DPD3 story. This is older than Philip. I mean, believe it or not.
30
it's
years?
From, yeah,
30 years?
Even older. It's from the last century. It's invented in 1957, and it's a good one, but it's really for organic. Yeah. It's not great.
Yeah.
However, in Switzerland, Germany, by regulation, we have to have all the pools below 0.2 total combined chlorine. No, they do not ask Dominic, explain me inorganic, organic. I don't care about this. I want total combined chlorine to be below 0.2.
Yep.
How do we do this?
And I think, Sean, we have in the US, it's 0.4 usually, or?
I believe so, yes.
0.4, right? So for me, you know, this is really important because the takeaway is the following. Regulations say that you cannot go over, let's stay in the US, over 0.4, right? So whether you have an AFM filter or a sand filter, you will get the same or a very similar DPD reading for combined chlorine because the reading cannot differentiate between inorganic and organic, and the regulators don't differentiate either. They don't care.
Yeah, I mean, just as a thinking, you know, for bioresistant filter media, you should measure monochloramine, which is easily done. DPD1 plus DPD2, and the difference is the monochloramine. And here you could set up the level lower, 0.1 ppm, we would be always in. We would be always in. But again, let's go into the public pools and see how that works in reality.
Exactly. What options do we have to reduce combined chlorine?
Yes, let's start with outdoor pool.
Yes.
Here, you will never have, probably also not with sand, but definitely not with AFM, you will never have any problem with combined chlorine. You will be always below 0.2. Why? Because we have a huge UV system.
The sun, right? At least in some parts of the country, right? We have it.
But Atlanta, you have quite a lot, and this makes photolysis. You know, it will oxidize. You know, the organic chloramine, the inorganic chloramine. This is a very big UV system, and if you add on top some ACO to the water, you make this formation of free radicals. You make it more effective. That's what the sun does. It will split water in free radicals. They are oxidizing the water. If you add ACO to the water, this is what we discussed in session number 8, you make it a lot more effective. So no problem. No, you don't have to worry anything. Outdoor pools always work.
The sun takes care of it.
Yeah.
Huh?
If you want to do it even better with ACO. Here's an example, Switzerland, 50-meter pool. Here it does not look busy. It's 5-6 years old, but here you see on the left side, there are 3 pools. It's a swimming pool, a children pool. The next one is a children pool, and then a non-swimmer pool. And you see all of these values.
Combined chlorine
total combined chlorine below 0.1, 0.05, 0.09, 0.05. And that was really at a very busy time. You see this at the water temperature.
That's in the 80s, high 80s.
Yeah, you know, and 3,000-4,000 people using the pool never have a problem. Also with the THMs, 25, outdoor pool, this is more than acceptable. The limit is 50, so all good. Turbidity below 0.1, you can't have it better. And reduce chlorine consumption, clear. And for those who are not familiar with German, he wrote here, Uli Frick, this is the operator, the manager there. but I translated it as a summary. I'm very happy with Daisy. Regards, Uli Frick, Hayden. So just to tell you, it works, and not one pool. I mean, here we have really a lot of big pools. We are just building now the big water park in Serbia with exactly the same technology.
Okay.
So indoor pool is the problem.
I have to interject really quick. I think that instead of CPO in the US, we have certified pool operators. We should have Bodmeisters. That sounds much cooler.
Waldmeister and Jägermeister.
Yes, exactly.
Okay.
Exactly. Okay.
Jägermeister comes in half an hour.
That's good. Okay, so let's move to indoor pools. Huh? One of the first, options we have, which is
the
also
first thing is
something
you don't have a sun.
Yeah.
You're missing the big UV system called the sun.
So you have to do something about combined chlorines. Huh?
If you don't do anything, you will be 0.3, 0.4. Yeah. With a reasonable, if you follow our rules, our sessions, you will be there, but you will not be 0.2. If you want to go to 0.2, if you have to go to 0.2, you have 3 options. Option 1.
You add a layer of activated carbon. This was covered in session 2. Okay, that's great. So very simple. On top of your AFM filter bed, you add, approximately 4 inches, 10 centimeters of activated carbon. This will be enough to cut your combined chlorine in half from 0.4 to 0.2. This will do the job.
Yeah, go to the next one. Yes. And it does it by the reaction as long as you still have oxidation. You still have chlorine in the water that goes through the carbon. You lose in 10 centimeters, roughly 50%. You will form on the surface of the carbon-free radicals. If you put a big layer in, often you say a lot helps a lot. Not true with carbon. Here with the carbon, really you shouldn't do that because after 20 centimeters, all your chlorine is gone. And then you don't have any more this catalytic reaction. Then the carbon becomes a sponge and it will biofoul. Yep. This is something we do not want. So that's fine. 10 centimeters, 4 inches, 4 inches is okay. That will go to 5 inches, it's okay as well. 3 inches, okay as well.
Yep.
All good.
Yep. So this is option 1, right?
Yeah, now, and it's a very good option. It's the cheapest option.
Are there alternatives to activate the carbon?
Yeah, go one more. Yes. And just as a reminder, that was also in session number 2, not anthracite N. That is not helping. There's a big confusion. Everybody calls everything carbon. This is wrong. We have to activate the carbon, very high surface, 1,000 square meters per gram, really for absorption. Anthracite N is not porous. It's just lighter than sand or AFM, and it's a bigger grain size. You can use this for room filtration. So don't use anthracite N in indoor pools. You could use it in outdoor pools as room filtration. I wouldn't do it. I prefer AFM. And you could use anthracite H, but this has 3 times less of surface that you would need 3 times more. I would not do it. It contains iron. So it is not good. In Germany, they do it because they have a lot of brown coal and then they want to get rid of this brown coal. Yeah. And they do not have a lot of coconut palms. So long story short, 10 centimeters of activated carbon. Best is coconut based.
Good. Okay. Next. So option 2 to remove combined chlorine.
Yeah. This is an option that you probably will not have too many of that. Maybe you have, I don't know, in the US. We have it quite often here, because our engineers, they spend hell of a money. This is if you have a high dose ozonization, where you dose 1 gram of per cubic meters of water that you treat of ozone. So if you have a 25-meter pool and you have 100 cubic meters of turnover rate, you dose 100 gram of ozone. You have then to go to a reaction tanks, let react it, and then you have to use a carbon filter to take it out. Here it's different. Here you need 20 centimeters of carbon because you want to remove all the ozone. Ozone in high concentration, if they come to the pool, they go to the surface, they are very toxic. So it gives a perfect water, but it's expensive. 100 gram ozonization system, you're talking about $100,000. That you do not need. You have to more or less the same result as with a Daisy system with a small layer of carbon, And you lose all the chlorine also,
Mhm.
because you have 20 centimeter or more of carbon.
Yeah.
So
And
you can do that. If you want to spend the money, you can do that. It's not wrong. We have a lot of these systems, and yeah, you can do that.
But we have better options, huh?
Yeah.
So option 3.
Do you have these systems in
Yeah, I was going to mention, you know, a lot of the times in my experience, and maybe Bill or Ralph or Steve can correct me if I'm wrong, but when we see ozone installations in the US, it's an ozonator on the return line back to the pool, and that's it. There's not a contact tank in most situations, and definitely not activated carbon to remove the ozone.
Okay,
the
that's
idea
perfect.
is that yeah.
Okay, that's perfect. That helps. But then you have to go for low dose ozonization.
Yes.
Like 0.1, maximum 0.2 grams per water that you treat. And this is a completely different story on the cost side.
Right.
If you do that, honestly, I would dose the ozone just in front of the pump. So you have a longer reaction tank. But yeah, that's another one. It will not make such a big effect on the combined chlorine.
Yeah, that's what I think. So it's more for disinfection than.
Yes, yeah,
it will make an effect, but it will not bring it from 0.4 to 0.2.
Yeah.
Right.
Okay.
Definitely not.
Maybe
Otherwise,
we can come back to this in the discussion at the end.
Sure,
if
sure.
One of you guys has something
Absolutely.
to add.
Absolutely. Or maybe we can give access to everybody so we can discuss it. We are in a small group, small family.
Exactly.
So solution number 3.
So solution number 3 is the use of a UV medium pressure. So we have same system. We have a DAISY system followed by UV medium pressure. We do recommend that if you use a UV medium pressure that you dose ACO in front, and we will explain you exactly why.
Yeah, and to be clear, that really will bring your combined chlorine down by 50%. So from 0.4 to 0.2. Yes, it is really reducing combined chlorine, but we form trilomethanes, as we will see.
Yeah.
And here comes why. Maybe we first explain, you know, can I have the commander? I know you're in charge, but you know, here you see low pressure and medium pressure. It's called here high pressure, but it's medium pressure. This is the wavelength, the curves that you have from a low pressure system. So it's between 250 and 260, and the peak is here at a 255. You see the medium pressure, which goes from 200 down to 300 nanometer. First lesson that we see, you need for medium pressure a lot more energy, at least 5 times more. But you need a lot more energy. And the second part, and look at the red curve, this is the hypochlorite acid. You know, you absorb quite a big amount of the hypochlorite acid at that point. You would absorb much less with a low pressure, but really with a medium pressure, you absorb a high quantity, 50%, if not more, of the chlorine. Now the question is, okay, then we go for low pressure, because less energy and less consumption of chlorine. No, unfortunately not. Why? Because you cannot oxidize. You cannot oxidize with low pressure UV inorganic combined chlorine. Let me explain you this. You have here the curves. Green is trichloramine, red is dichloramine, and black is monochloramine. And you see the absorption point here is 210 nanometer, 220 nanometer, and here 230 nanometer. Here, roughly at 250, you have nearly no absorption. I mean, you have 5%, but this is not what you want. You want to reduce it from 0.4 to 0.2. And this is why low pressure does not work. So inorganic combined chlorine is really only reduced with medium pressure UV. Organic chloramine is absorbed by medium pressure and by low pressure. The curves, I don't know exactly how the curves go. It's somewhere here. So organic chloramine is reduced with low pressure roughly by 25%, with medium pressure roughly by 50%. But as a takeaway, you have really to use medium pressure if you want to dechloraminate, to reduce your combined chlorine. And it has side effects.
Yes, when you oxidize inorganic chloramine, then you are producing nitrate. NO3. Nitrate is a food source. It's a fertilizer. So you will most likely see algae growth, bacteria growth in your pool.
Yeah. So here you find the formula. This is from our friend Howard, where the trichloramine with water is converted to nitrate. And the levels can get quite significant. But the main, and honestly, do we want this nitrate? No, we don't. But why we are against this treatment, why we are really not fan of it, let's call it a little bit in a more gentle way, because maybe I do not make too many friends in the UV industry today.
You already
well,
lost.
I have one friend. I've shown this is good enough.
You already lost.
The problem is really that you form these trilomethanes, and this is what Philip explained. You know, you have big molecules, and with this photolysis, you split them in smaller ones, and the smaller ones is 1 carbon, 4 hydrogen, which is a methane, which forms trilomethanes. And you will see it then in the case study that this is true. Because when Howard came out with this message, and this was 2007 or so, you know, the UV industry here in Europe, they want to kill him, or at least to shut up his mouth. And yeah, good. Short thing about this. If you do, you know, again, if you say, Dominic, I don't care, I love UV, great, I have these systems installed, then you still can improve your system by dosing a small amount on permanent ACO in front of your UV medium pressure. Here, black, you see the curve from the medium pressure without ACO, and red, you see it with ACO. And clearly you see when the wavelengths get below 350 nanometers, you know, we deflect these short wavelengths in the longer wavelengths. With this, you get some energy where you produce a certain amount of free radicals which chop up complete oxidation, then organics that you have in the water. And this is how you reduce your THMs. So really with UV, you know, you might increase your THMs by 50%. If you add ACO, maybe only by 25%. So yeah, this would be good. That would be good. That would be also help our budget, right, Sean? We love to sell.
Really?
Also ACO, AFM is good. ACO is also good.
Yep.
Yeah.
Sure.
Yeah, we have a lot. We do have quite a few people using ACO on indoor pools with medium pressure UV successfully.
And what's the experience? I mean, is this you have to say it's true. No, forget about me. Forget about Philip. Give me really your experience.
Yeah, so we have a number of indoor swim schools, which obviously that's a very important application. We don't want to have a lot of THMs in indoor swim schools with children in them. And, you know, began dosing the ACO and noticed that they were consuming less chlorine, much clearer water. They reduced trichloramine smell significantly. These are even pools that have not yet switched to AFM, but still have sand. So they're using ACO with medium pressure in sand. You know, and I'm not 100% sure, but I believe we have one with a DE filter as well. So it's working in all systems, and very, very positive feedback. I've not heard one story of anyone being disappointed with ACO and a medium pressure UV system on an
okay, if Sean is telling the truth, and I'm sure you're doing it, you said clear water. Why? Because we have free radicals, complete oxidation. You said less of chlorine smell. Why? Complete oxidation of the trichloramines. And savings of the chlorine. Yes, because you have less of wavelength. So it's a sun blocker. You protect. It's like with the sun, you know, UV medium pressure is a little bit like the sun. And if the ACO does the job with the sun, it also does the job with the UV medium pressure. Agree? Well explained?
Yeah, I think so.
Yeah.
You have to ask our viewers then at the end.
Okay, hands up.
They will be.
Okay. Philip is the king of the summaries.
Let's summarize what we just discussed. Okay, so what we've learned is UV medium pressure cause photolysis, are breaking down chlorine, free chlorine. They're also breaking down chloramines or combined chlorine and organics that are in the water. That's number one. I think we know that, but we have confirmation on this. Short wavelengths break down organic molecules into smaller components that react with chlorine, and we have the formation of chloroform. This is the main reason why we don't like the use of medium pressure UV, because they form chloroform and THS.
And this is not measured yet in the US, but it will come. Yeah. And it's really, I mean, for all parents, all grandparents, you know, if you have babies, you should be careful using pools.
Yes. Then we have the formation of nitrate, which is kind of a negative side effect that's not overly important, but you know, we should be aware of this. ACO absorbs the shortwave UV light and creates free radicals. This is why it is a good addition. It's a good idea to dose it before the UV medium pressure.
Sean said this.
Yeah.
And he's right.
Yeah, absolutely.
And he's helping then our budget. You're helping our budget, but you also do something good for the environment. You do something good for the users. So this is really good. Okay, here case study, Bad Hesselingen, and this is really our main test pool. It's in Netherlands. It's a 25-meter pool. What is this, 50 feet?
25 yards.
Yeah, big pool, 5,500 visitors. And, you know, here we had really we had run the system still in the old situation. That was sand with flocculation for 2 months and took all the data. And then we run it AFM and APF for 7 months. Then we added a UV. In this case, I apologize, it was not medium pressure, it was low pressure. And you see then the results. Again, low pressure works with organochloramine, doesn't work with inorganic. And then stage number 3, we had the 4 inches of activated carbon layer. The pool was always tested once per month, same day, same time, to have more or less equal situations. And here, these are the parameters which were tested. So turbidity, pH, free chlorine, total chlorine, combined chlorine, KMNO4, oxidability, urea, aerobe temperature, Pseudomonas aeruginosa, intestinal. I can't spell these animals here, terrible. We talk about this in session number Clostridia,
Session 9,
I was not good in Latin. Legionella, chlorates, THMs, everything. Trichloramine in the air. You know, 36 parameters. And this is why, each test was 1,000 euros, $1,000, let's say. And these are the results. You want to take them?
Yeah, okay. So what we see here on the left are the parameters. We see stage 0, which was the old sand configuration. We want to highlight 2 parameters here. One is combined chlorine, which was, you know, average of 0.6, and this KMNO4 8.3, so around 10 maybe. Then we move to stage number 1, which was sand and the flocculant they were using was replaced with AFM and APF, coagulant and flocculant. And then what you can see here is the development over a period of 6 months, roughly. And you can see immediately after changing over to AFM and APF, actually these 2 values jumped up significantly.
Terrible.
Before they went then down, you know.
And why was this? You know, the customer, Pomats in Netherlands, they called me and said, Dominic, Houston, we have a problem. Jump in a plane and come here. It's terrible. You know, the values, combined chlorine, it's even worse than it was with sand.
What did you sell us?
What did you sell us? What shit is this? So I said, hey, guys, I'm sure you're not backwashing the filters. Yeah, we are doing. They have 2 pumps, you know, to backwash the filter, etc., etc. So I can't believe it. I come tomorrow, but please first go there. I knew there is a side class and make a video about the backwash process. So 2 hours, they called me and said, the bed is not moving. We instructed the operator to do it, to backwash with 2 pumps. This idiot, he's backwashing with 1 pump, and the other one pump, he even slowed down in the backwash process. Why? Because he lost a little bit of AFM, and then he was scared, and then the bed was not moving. And by the way, you know, if you see here 19.5, this is 5 is for May, and this was April.
Yeah.
You know, the results were good week number 1, and then week 2 became less good, less, and then after 5 weeks, you know, you were in this disaster. So they didn't change anything. They just went back to the old backwash regime, backwashing it with 45 meters per hour instead of 20 meters.
20 gallon per minute.
20 gallon.
And square foot.
And here they were backwashing. Red was a backwash at how many gallons? 8?
What was it in meters? 20?
20, less than 20.
8 gallon per minute per square foot.
This is if you backwash it, and this was the old AFM at 8 gallons, and this is then the result with the 20. So you see, if you do it the wrong way, your result is not great. It's terrible. But if you do it right, you know, the result is great. And then with the combined chlorine, we dropped by 25%. Again, this was low pressure UV. Medium pressure probably would have dropped to 0.2. No really change in the oxidability in the KMnO4. And then with the carbon, you see 0.1 on total combined chlorine. And here again on the oxidability, stable. You know, not really a change between stage 1, 2, and 3, but a big change to stage 0. Roughly 50% than what we had. So yeah, with the good backwash, they were happy. And few more, here we go. Turbidity, we were at 0.5, and then you see here in average below 0.2. THMs, more than 50, and here again, you know, roughly around 25 to 30. Here with UV, you go up. You go up by 50%. Without UV, here with carbon, again, you go on the same value. This is also large, you know, it always goes with the KMnO4. Not here, it does not go with the KMnO4. Here you have the UV radiation, the photons who split down big molecules and smaller ones, and this is how you form it. And then trichloramine in the air. This is quite complicated to measure it. You know, you have a pump where you pump air for 1 hour. That goes through a filter, and then you analyze this filter. So this is a little bit more complicated, but you see we were here before roughly around 500, and here less than 250, usually even less than 200. There is a little bit of variety because it's atmospheric test. And if you move the water a lot, if you have a lot of activities, you have more gases out. And all this, ladies and gentlemen, you know, with half of the fresh water, because they made big savings in using the filters. Before they were backwashing the filters at 60 meters per hour. What is this?
24 gallons per minute per
24.
square foot.
So they dropped to 20, and instead of 6 minutes, they did 4 minutes. So they made quite some savings in water. So as a summary, with half of the fresh water, half of the disinfection byproducts, and that's a factor of 5. Maybe you show it in the overview.
Okay, so I really like this next slide here for everyone who's a bit more visual like me, you know, rather than just numbers. So
yeah, I'm more the number guys.
5 parameters, huh?
And we took out here the dirty week.
Yes, exactly.
We took this out. We showed it to you.
First week here.
Yeah, this first month.
Okay, so significant drop of turbidity, you know, to 0.1, 0.2 NTU. So this is the product promise of AFM and APF. So this is what you can expect, obviously. Then significant reduction of combined chlorine, you know, roughly by, well, more than 50% reduction.
Yeah, but that's not a promise. Really, a DAISY system will bring you indoor pools roughly to 0.4, roughly to 0.4, 0.5, 0.3 average. 0.4.
And you can see a further reduction after they turned on the UV. And then if you activate the carbon, then you really take the combined chlorine down.
Yeah, and the medium pressure would have brought this to 0.2. So medium pressure does a good job on the combined chlorine, but not on the THMs. Yes. This is what we see here now.
So THMs, a reduction of about 50% with AFM, APF. And then what you see here is that the reading jumps up again as you turn on the UV. This is exactly what we said.
And that would be with medium pressure even higher.
Yes.
Even higher, because you have more energy. You can split more molecules into smaller ones. So this is the only reason why we are not fan of UV medium pressure. That's the only one.
Yep. Trichloramines, also a significant reduction here to this level. No change with UV, and this is just the statistics, you know.
Yeah, maybe the pool was a little bit more busy. This is when it
more
went
or less,
up here and less
flat.
busy, you know. This is trichloramine in the air is a little bit more difficult, but really the takeaway from this is Daisy solves everything beside the combined chlorine. For combined chlorine, if you want to be below 0.2, you need carbon, UV, which we would not recommend, ozone, or the new solution that we will present to you. Yeah.
Good.
Clear.
This, I think we have covered.
Yeah, they talk here about the savings they did. Payback was 2 years. Promise was 5. Reality was 2. Now we come to something which is brand new in this industry, really worldwide brand new. It's not new as technology. It's called advanced oxidation. So what's that advanced oxidation? Okay. Okay. Good.
Let's go to the Star Wars slide here.
Star Wars slide. Yeah. This is advanced oxidation. What you do, advanced oxidation is oxidation with hydroxyl radicals. And the best way, and there are different ways, DHA, ACO, the sun itself, but small amounts. If you want to produce a massive amount of free radicals, the way to do it is that you split water peroxide, H2O2, that you split this. How you do this? Most effective if you have a very, very high dose of UV. You know, these photons here, these Star Wars things jump in. It looks a little bit like how it's called from Elon Musk. You know, yeah. However, you know, you see these photons jumping in and cracking here the hydrogen peroxide into hydroxyl radicals. And then they go to the contaminant and they oxidize all the bonds. No disaffection byproducts. And this is why you use them very often in wastewater, especially industrial wastewater, you know, where you have heavy toxics like benzidine, etc. If you want to remove them, the best way, the cheapest way to do this is hydroxyl radicals. Yeah. And by the way, this is where we learned it, you know, this. We have seen this in one of our applications in water treatment. And one back here. And that you need very strong UV radiation. You need, what is this?
177,000 per square foot.
Are you sure?
It seems a bit high, but...
yeah, it's 5,000 joule per square meter. Can't be, I mean...
Yeah.
Forget about this. It's strong. What I can tell you, you know, I know that the European numbers. It's 5,000 joule per square meter. Maybe Sean, you can do the math. 5,000 joule per square meter. I mean, to make a comparison, drinking water that you also disinfect with low pressure UV, not with medium pressure UV. With low pressure UV, you have a dose of 400 joules per square meter. Here we go with an intensity which is 12 times more. But we need this really to split the peroxide into hydroxyl radicals. And then they do the job. They oxidize everything which goes through this.
Yeah, it's 53,800 joules.
53,000.
800 per square foot. Yeah.
Yeah. Okay. 50.
I used cubic feet in my previous math. That's why. That's why.
Can you do me a favor? Can you do me a favor? Can you change it then in the presentation?
Yes,
so
I will. Yes.
Yeah.
Because we also want to upload then all the presentations later on, also on our website, so you can check it.
Sean, I'll double check it too, huh?
Okay.
You don't trust him?
Yeah, you know, it's two guys, two brains to make sure it's correct.
Yeah, good.
Okay.
I think he's right, by the way. It's about 10 times more. So yeah. Good.
Yeah.
So we do this together. I mean, we are not manufacturing UV. We do it here now in Europe. In America, we would go for an American supplier where we can partner up. You know, we use here Van Bremen because they are in Europe. They are the best in
Dutch
they are
company,
Dutch,
huh?
yeah. But in low pressure UV, they are very perfect. And we are the best in filtration and in water chemistry. And Howard said, okay, why don't we bring advanced oxidation in here and we just treat a small side stream, a very small side stream. And Philip will we leave this out. As good as ozone.
Yeah. Okay, so why this? Because this really is a really big advantage that we only need to treat the water in a very small side stream, and the side stream is, you know, about 3% of the water volume. But really, the main reason is because the organics, the organic chloramines.
We have one, but maybe first to this. We call this new baby Advanox.
Yeah.
Advanced oxidation. If you take this out, it's called Advanox.
Advanox. It's a nice name.
It only works with Daisy.
Mm-hmm.
Why, Philip?
Okay, so we take it in a side stream. It only works with the, let me answer this question first. So you need to have a Daisy to bring the oxidation demand down. That's one important reason. Another important reason is you do it because we take down the amount of inorganic chloramines, which build up very quickly, but organic chloramines build up very slowly. And this is the reason why we can treat the water in a side stream. So if we see the water every 2.5 to 3 days going through the Advanox, then this will be enough to make sure we can get these organic chloramine level down.
Yeah. Okay. Let me really point this out. This was exactly right. Yeah, oxidation demand is not that important. It's really about, we have organic chloramines. 80–90% is organic chloramines. Because of Daisy, we have very low values of inorganic. Mm-hmm. Inorganic, as you said, they can build up in minutes, in hours. Yeah. But not organic chloramines. They are building up slowly over days. And this is why it's absolutely okay to treat once per every 2 to every 3 days the water. If you take this here as an example, this Breitenbach again, it's a 180 cubic meters pool, very, very busy.
50,000 gallon, yes.
Yeah, very busy. And you pass this every 2 to 3 days. So I took 2.5 days, this is 60 hours. So you take your pool volume, you divide it by 60, and this gives you the 13 gallons per minute that you have to treat, only this. Okay?
Exactly.
And how you do it, you install a bypass pump.
So we install a bypass here, we install a bypass pump.
Smallest pump that you find, you know, $200.
Yeah. Ideally also a flow-vis, a flow meter.
Not ideally, please do it, so you can control the flows. You have to know, do I have 30 gallons per minute, or do I have 30? Otherwise, we don't have any more the right dose.
And the dosing pump for your peroxide.
Yeah, and a small one, you know, the same that we use for flocculation. Because you have to dose this peroxide on permanence. It's not helping if you dose 1 minute and then you stop 59 minutes. You have to dose it on permanence.
Continuously.
Small, but on permanence.
Yeah.
Yep.
Continuous dosage.
Yes.
And I'll interject because we have a few different manufacturers in the US that are producing advanced oxidation systems that are really, they're either a UV cell or an ozonator that they're calling advanced oxidation. While they may have a little bit of advanced oxidation occurring in those systems, it is nowhere near the amount of hydroxyl radical production that we're achieving with these systems. So when we say advanced oxidation, I don't want anyone to get to have a bad opinion of it because of what's going on currently in the US. This is completely different and produces a large amount of the free radicals, and that's why we need such a powerful or such a high level of UV exposure in this application.
Mm-hmm.
So just keep that in mind when you hear advanced oxidation. This is truly producing effective advanced oxidation, not as a disinfectant, but as a way to reduce the organic chloramines.
Yeah, we also have these systems in Europe, and they are okay, you know, for private pools, but nothing for public pools. I mean,
Right.
mainly ozonization, 2 grams, let's say, and then you destroy it with the UV. In this process, you will form small amount of free radicals. Absolutely, absolutely okay. But this is like you compare a bike with a truck. You know, a bike can carry 50 kilos, a truck, 20 tons.
Good.
So it's really different.
Yep, we need to hurry up a little bit. Okay.
Why?
Anything
You're not
to add
enjoying
here?
it. Okay, the important is pass every 2 to 3 days one through the Advanox. And we need, and if you follow our instruction with this 5,000 joules, and you know there are other UV manufacturers in the US, it's not complicated. But let's test it out first a little bit more here in Europe.
Exactly. Dosing rates, you know, depending on the concentration of the hydrogen peroxide.
Yeah, but I believe you still are allowed to sell 35% concentration, right? You're not so paranoid like the Germans and the French guys.
Yeah. So small dosing rate also.
Yeah.
Okay, one more thing to highlight. If you look into the inside of the Advanox, you can see it's like a spiral around the UV lamp. This is to make sure that the water is brought as close as possible to the UV lamp, because the closer to the UV, the stronger this UV radiation is.
Yeah, and this is why really our unit, we know that works perfectly.
Yeah.
If you go to one where you don't have this mixing flow, it will work much less good. For this, we know how good it is. It's not well, I don't know the American systems, but that would be maybe something that you should have a look
at that. Yeah, absolutely. Okay, results. Here's from a case study from actually very nearby. We have the green line, which is the free chlorine, just as an indication. Then we see the red line, which is a DAISY system. You see combined chlorine between 3 and 4, between 0.3 and 0.4 ppms. And
so
then,
average 0.34. Really just concentrate on the red. This is a DAISY, no carbon, nothing. Yeah, and as I said, you will be below 0.4 or in average below 0.4, but you will not reach 0.2.
Exactly. And then DAISY Advanox, your Advanox is turned on. And you can see that we are right around 0.1 ppm of combined chlorine.
Yeah.
No?
And then slightly blue, you see the monochloramine, which is really not affected by the Advanox because you only pass it so few. This comes really from the DAISY. Because of DAISY, you have very small monochloramine. So you can't do it better.
Yeah.
I mean, you can't.
Right. So,
or at least I do not know how you can do it better.
Yeah. So
it's a busy pool.
One extra thing that you're getting with the Advanox,
the bonus
in combination with peroxide, is the efficient removal of pharmaceuticals and cosmetics. You can see here a whole bunch of different substances that I cannot pronounce. But what you can see is the orange bar, which is the removal efficiency of ACO together with an Advanox system.
So here we dosed ACO instead of peroxide. We wanted to try this out because that also forms free radicals, but it was not so effective.
Yeah.
But we added it here that you see what's the difference with the peroxide. Removal rate 100%.
Yeah.
I mean, for me, it was not a surprise, but here you clearly see it. We have seen it, as I said, you know, in water treatment with benzidine, and benzidine is one of the most difficult chemicals to break down. So this you get on top. This is why you use today advanced oxidation really in wastewater, especially industrial wastewater. And they all do it the same way, always high dose UV, low pressure, 5,000 joules, and then peroxide.
Okay, good. So let's summarize. Why is Advanox better than UV medium pressure? First thing we learned is medium pressure is generating a lot of THMs. It's also consuming a lot of the free chlorine. UV medium pressure is also relatively expensive. So you have relatively high CapEx and OpEx because you have higher power consumption.
Much higher.
You're
Instead
generating,
of 600 watts, you have 6 kilowatts.
Yeah.
So
it's
it's
a factor
big.
of 10, huh?
Yeah. At least 5.
Yeah. Okay. You're also generating more heat, which means you have more scaling on the UV lamp. And you have a shorter lifetime. I believe it's usually around 8,000 hours versus 12 to 15,000 hours that you get with Advanox.
We recommend to change them every 12,000 hours. They would live every 15,000 hours would work as well. But that's under us, on the friends, right?
And then the solution with the AFM and activate the carbon, you know, Advanox has the advantage that we have no loss of chlorine. That when you use activate the carbon after backwash, often you have to, I think, or maybe always, you have to go in a rinse phase. So you don't have the black dust in the water. And when you have a situation when your filter bed is not flat, your carbon layer is not equal, then you have some issues, which you don't have with an Advanox.
I really like the carbon solution. I mean, we have it so many times installed, easy, best, cheap.
Yeah.
But Advanox is even better.
Yeah. Okay.
It's the best solution that you see here on the left. For me, it's the best solution. And if you go to the next, much better than UV, much healthier, much better.
Yeah.
I think it's as good as a very expensive ozone system, high ozonization system with reaction tank, etc. I think it's even better, but at a fraction of the cost.
Absolutely.
Okay.
Much cheaper. Much cheaper.
Yeah, here a little bit. Yeah, that's in euro, but yeah, it's not expensive. I mean, it's not free of charge. You know, we're talking about $12,000 for a 500 cubic meter pool. That would be how many gallons?
130, around 135,000 gallons.
Yeah. So it's a 25 meter pool, 25 yards. So quite big. Yeah. Okay,
these are list prices.
These are list prices.
Yes.
You get 2% of this.
Okay.
No,
so exactly. So why a daisy again? That you need to have a daisy in order to reduce your inorganic chloramines. And now you're adding exactly. So now you're adding Advanox to reduce your organic chloramines, and this combined will give your total combined chlorine reading to below 0.2.
And there is nothing better, I know, at the moment on the market.
Yeah.
We are still missing experience. You know, we have tested 2 pools. We have ordered now 20 units. They are arriving next week, and then they go all over Europe to all our international European partners. And in 6 months, we will have a lot more data. But I believe it's a game changer.
Yes. I will come back with more data from Europe as soon as we have that ready. In the meantime, if you're interested, drop me an email and we can talk.
And we can bring this to America, and we do not have to sell the unit. You know, maybe we partner up with somebody who is good. So Philip is more than open for your suggestion, you know,
absolutely.
And then we can test this out sooner. We don't have to sell this, you know, if you have a good partner, just follow the rules, bring in the daisy, and then we are okay. Okay, today in a week, we are talking session number 9 about pathogens. So again, about these terrible animals, which I cannot spell. And we talked already about this. We will talk again, but especially also if you have them, we will talk about how you can avoid them. But if you have them, what can you do?
Good.
Yeah. Okay.
Let's see what questions we have, comments.